Hello, guys. How are you? Welcome to our part B in our introduction to calculus, where we begin our discussion of set theory. In this video, what we are going to mainly discuss is some operations that can be done with set. So I can say today's heading is all about set operations. You see. So one thing that we're going to realize that is quite common in how mathematics is created whenever it's created. Mathematics always begins by creating first a space in which everything is going to live in. And then after a space has been created, the next stage that always comes after that is always the creation of objects that are going to reside within that particular space. And when the objects have been defined, which are going to reside in that particular space, the next thing that we mainly care about is how we can create new objects from the ones that are already there within that particular space. You see that? So this is how mathematics is being created. When new branches of mathematics are being developed, you will see that the creation mechanism always works in that particular order. First, establishing a space, objects, and then operations. So already, if you come and look here, what we've done, this is exactly what we have done. We have now created a platform which is sets, and we have now created the objects that resides within set. The next thing that we want is how can we create new sets from the old sets that we have. So that's what we're going to learn in this lesson today. You see that? So there are many different operations that can be performed with sets that have been defined so far. But what we're going to focus mostly mainly on is the following operations. We're going to talk about the union operation of sets. We are going to talk about the intersection operation of sets. And then we are going to also talk about what is called a set difference. And afterwards, we are going to talk about the complement of a set. So that's what this lesson is going to be about. We are going to look at these 4 different operations that one can do with sets, and then understand how to do them. And then that will be actually a good foundation for someone now who would like to start going deep into the study of calculus. You see. So without taking much time, let's get to work. So now let's talk about the union operation. You see that? So what is the union operation? So the union operation, given sets, given sets such as A and B, we have the union operation, which is denoted as A union B, defined as follows. So in set theory, there is this operation that one can perform using 2 or more sets, which is called the union of sets. You see that? And when the sets are represented by the letters A and B uppercase, then the union is represented by this cup, which is not a U. It looks like a U, but is called the cup mostly in mathematics. So if you have A cup B, it means A union B in mathematics. And this union is defined as follows. So A union B is defined as the set which consists A such that this A that belongs to A, or this A that belongs to B. You see that? So that's how the union is formally defined. But let's understand exactly what is the union. You see that? So in simple terms, what we call the union of sets is just the combination of the sets A and B to become one set. That's what the union operator. So it's more like unite. You see, so union is a term which is actually derived from unite, meaning make one. So whatever you're given, when they say find the union of those, it means you just have to unite them to just become one single set. You see that? So that's how the union operator works most of the time. You see that? But most of the time when we just state it plainly like this and say you just have to unite the two sets together, it is kind of misleading how one can do it if is not shown maybe a particular example which demonstrates how exactly to perform the union operation. You see that? So now what we're going to do now is we're going to look at an example in which we are going to perform the set union so that we just see what are the rules or what are the things that you must make sure that you stick to when you are doing this combination of sets to become one single set. So let's consider the following example. So one particular example that can get in an exam is something like this. So you can be given maybe a set A, which is defined as 1, 3, 4, 6, 7, and another one B, which is defined as 3, 4, 7, 9. Then you might be then asked to say find A union B. That can be a particular question that you can get in set theory where you're given two sets and then they say find the union of that set. So how do we actually establish the union of two sets? So now we are going to see how exactly the union is done correctly. You see that? So remember, union means combine these two to become one single set. But if you can look closely in these two sets that were given, you will see that there are some elements that are actually seem to be appearing in both sets. So if you check, there's 3, which we can see even that other side. There's a 4, which we can even see that other side. There's a 7, which you can actually see that other side as well. You see that? So when you are combining or forming a union of two sets, you do not repeat elements twice that seem to appear in both of the two sets. You see that? So what you do is, even if an element seems to be there in one set and also in the other set, you only put one representative of that element in the union. You see that? Which means the union in this particular case will be as follows. So we'll have 1, and then we'll have this 3, then we'll have this 4 again, then we'll have a 6, then we'll have a 7, then we'll have that 9 which resides there. So this is how we actually determine the union. It's the combination of sets in such a way that everything that was seen in the two sets that were given separately is seen also in this individual set that is given here. But they should not be a repetition of an element more than once in that union. You see? So this is how the union operation works in mathematics, and you must make sure that you do it correctly all the time when you are asked to do it. You see? Then the next thing that we want to talk about is the intersection. So we have another operation again, which we have mentioned, which is the intersection. You see that? So given the sets A and B, we have the intersection operation defined, or let's not first start there, denoted by A cap B. So now the intersection is represented by the cap. So it's more like a tilted cap which faces down, defined as follows. So this thing that we refer to as the intersection, it is defined as follows. So A intersection B it is the set which consists of elements A such that A is an element of A, and at the same time that A again is an element of B. This is how we formally define the intersection. But such a definition, which is abstract, can be quite difficult to understand. So in simple terms, the intersection is just a set of elements common to the two given sets. You see, so the intersection is a set which takes the things that are common between these two given sets. You see that? So when you see an element which is shared by both these two sets, that's what makes up what we call an intersection. You see that? Like if you take these two in real life, we usually talk about a T-junction as an intersection, because it is a point where two rods actually share the same particular point. So it is the same analogy even here. When we talk about intersection of sets, we're talking about things that are shared by the two sets. You see that? What elements are shared by these two given sets that have been defined. That's what the intersection really is. So let's do also an example to see how one can work out the intersection. So a particular example will be something like this then. So given A, which is 1, 3, 4, 7, 9, and B, the set which is 3, 7, 10, 11, find A intersection B, like that. So how will you go about finding the intersection? So to find the intersection, this is how you will proceed. So you will say what is A intersection B. Then to look at the intersection, what you simply do is you look at the things that are common. So what are the things that are common? We see this 3, which is this 3. We see this 7, which is this 7. And we don't see anything other than this 3 and 7, which seem to be shared between the sets, which means the intersection is just 3, 7 in this case. So this is how the set operation works most of the time. You see that? So this is what we call the intersection operator, which asks for what things are common between the two sets. Then again, we have another operation which is known as the set difference. So it's more like the subtraction of sets, but it's not necessarily subtraction. So it's called the set difference, and we are going to see how it works. You see that? So given two sets, A and B, we have the set difference. So we have something called the set difference, denoted as A minus B, or A over B, like that. You see that? So we have this thing that is called the set difference, which is defined as A minus B, or A backslash B, like that. You see that? Defined as, so what is the set difference? What is A minus B, which is actually the same thing as saying A over B. So A minus B, or A minus B, it is the set which consists of A element A, where A is an element of A, and at the same time, this A is not an element of B. So that's what the difference is. It is everything in A which is not contained in B. That's exactly what the set difference is. But there's a notation that I so far introduced. It's good that as far as you learn mathematics, you learn some certain notation that you're going to see. So there is this notation that is normally used. So it means and. So when you see this head, which it looks like a V, which has been written upside down, it stands for and in mathematics, and it's going to be quite common. And also there is another one which is almost of the same nature, which forces like that. So when you see this in mathematics, it means or. You see that? So when you meet something like, it means A or B. So it's notation also that is quite cool for you to know at this stage, though mostly you might not be making use of it at this point in time, but it's good to know. So in simple terms, a set difference means everything in set A not contained in B. That's what a set difference really is. You see that? So it means everything that is found within set A, but which is not in B. So to understand exactly how this works, let's look at the following example. So let's look at the following example 3. So given A to be the set 1, 3, 4, 6, 7, and B to be the set 3, 4, 5, 9, find A over B, like this. You see, so how do you find A over B, which means A minus B? So the solution goes as follows. So if you want to find A over B, what you simply do is you have to first go into set A and look at everything which you can see that is in B. So like for example, if you look, this thing is also contained in B. This thing is also contained in B. Is there anything else that we see that is contained in B that in set A? We see there is no such, which means now what you have to do is to write all the other remaining things in A which are not in B. So which is 1, 6, and 7. So this is what we call the set difference. You see that? This is what we call the set difference. So it's good to be aware of all these operations right now as you're starting your studies in calculus, because now when they start popping up in calculus, no one will be taking time to explain what is the meaning of all these things to you. So it's good to get the foundation right so that when you move on to the study of advanced calculus courses, you don't have to be challenged by all this basic stuff. You see. So now let's move on to the last thing that we want to discuss today, which is the set complement. You see that? So it's more like an operation of sets, which I can take as a unary operator, but we're going to see exactly what it is. You see that? So one of the things that you should know is that when it comes to set theory, we always work with individual sets like A, B, and C, as we have seen in most examples that we have come across so far. But one thing that you should always have at the back of your mind is that everything that we deal with in mathematics must come from somewhere. You see that? So even those particular sets that you'll be given at that point in time, it's not something that has just been created from nothing. All sets, they come from a certain bigger set, which we can say is like the whole universe of set. You see that? So set, they live in their own universe, which we usually refer to it in mathematics as the universal set. You see that? So one thing that you should know is that if you have individual sets such as A, B, or maybe some C, which also resides like that, you should always know that at the back of your mind, they always exist a much bigger sets which consist in its interior all these individual sets that have been given to you. You see that? And we actually refer to this big set in which every set lives as the universal set. You see that? And mostly it is denoted by some funny symbol, which I don't even know how to write it, but in most books they use different symbols. Some they can even use a Kelly U, which bars like that, to mean universal set. But this is something that you should always have at the back of your mind. But it is not always necessary to always bring about the universal set when it's not needed. You see that? But every time when complements are involved, it is that time within which you must always bring about the universal set. Because for me to define what is called a universal set, we might always need to have, to define the complement, you might always have a need of the universal set, because without the universal set, it's impossible to define what a complement really is. You see that? So, but one thing that you should always know again is that sometimes a universal set doesn't need to be the whole universe. You see that? It can be just a big set which contains all the small sets that are given to you. So it doesn't necessarily have to be the whole universe. Like now, us living in a Milky Way universe in which there are all these different galaxies inside. So sometimes it won't be always necessary for us to try and look at the whole universe as a whole. You see, it will be sufficient just to look at those small galaxies and try to just see what we can say within those confinements. So it is the same thing even here. We don't have to always term the universal set as the set of everything, but it can be a big set which consists, which is large enough in such a way that these small sets that we have, they are just within its interior, like that. You see. So now when we have this thing that is called the universal set, it is now easy to then define what a complement really is. You see that? So what is a complement? So given a set A, we have the complement of a set A. We have the complement of a set A, which is denoted either as A prime or A small c, like that, you see. And this complement is defined as follows. So we have this thing that is called the set complement, which is defined as follows. So the A set complement, which I will just denote as A prime, because that's what mostly is used in many books. But you should be aware that also there is AC, which also stands for the same thing. So A complement, in simple terms, it can be defined as the universal set minus the set A. You see that? So that's what the complement is. So the complement is just the difference between the universal set and that particular set. So which means now when we put it in notation, it is A such that A is an element of the universal set, and at the same time this A is not an element of A, like that. You see, so that's what we call the complement. So the complement of a set is defined as such. You see, but in order for us to understand how things work, let's look at a particular example in which we can try and practice this. You see, so a typical example that you can find would be something like this. So you'll be saying, given maybe the universal set U, which consists of numbers 1, 2, 3, ... up to 20, and then given a set A, which is given maybe 2, 4, 5, 9, 10, 11, and another set again B, which consists of 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, like that. You see. Then you may be asked to say, find B complement. That can be a question that you can be asked. Find B complement. So how do you get B complement now? So to get B complement, this is how we proceed. First, we know that B complement means the universal set subtracting B. So which is what? Which means I have to write everything that is inside the universal set, but I must make sure that everything that I write is not in B. But if you look at what is in B, you will see that B has all the odd numbers. You see that? So this set B has all the odd numbers. But the universal set has all numbers from 1 to 20, which means what I just have to do, I have to delete all the odd numbers and write only the even numbers. So the remaining even numbers, which is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 is exactly the complement that we are looking for. You see that? So yeah, that's it about the basic set theory. Though it's not exactly the entire thing that you should know about sets, but for a startup of a calculus course, this will be sufficient information for you to know for now and work with. But for students who are going to then take an algebra course, you will still have to go much more further than this. And I plan to add more videos to further the set theory to even cater for students who will be doing courses that are much more abstract, especially in that algebra dimension. Otherwise, thanks for watching, guys. I will just end the lesson here today. Thank you. Bye.